We have a large square, ABCD. Inside the square, tucked perfectly into the bottom left corner at point A, is a quarter circle. Everything inside the square, but outside the quarter circle, is shaded green. And our goal is simple. Find the exact area of that green region. Now let's examine the information we're given. On the left side of the square, there is a point E. The small segment from D to E measures exactly 1 unit. From point E, a horizontal segment extends to the right and touches the quarter circle at point F. And we are told that EF is exactly 2 units long. So how do we find the shaded area? Well, if we know the area of the square and the area of the quarter circle, then the shaded area is simply square area minus quarter circle area. That means everything comes down to finding the radius. Let's call the radius of the quarter circle r. Since the quarter circle fits perfectly inside the square, the radius is also the side length of the square. Now look carefully at the left side of the square. Its total length is r. The top segment, DE, is 1 unit, so the remaining segment, AE, must be r minus 1. And now comes the observation that unlocks the entire puzzle. Draw a straight line from A to F. Since A is the center of the quarter circle and F lies on the circle itself, the segment AF is a radius, so AF has length r. Look at the shape we've just created. Triangle AEF is a right triangle. Its vertical side is r minus 1. Its horizontal side is 2. And its hypotenuse is r. Perfect! That means we can use the Pythagorean theorem. The quantity r minus 1 squared plus 2 squared equals r squared. Let's expand everything. The quantity r minus 1 squared becomes r squared minus 2r plus 1. And 2 squared is 4. So we get r squared minus 2r plus 5 equals r squared. And now something very nice happens. There is an r squared on both sides. They cancel immediately, leaving us with negative 2r plus 5 equals 0. Add 2r to both sides. We get 5 equals 2r. And dividing by 2 gives r equals 5 over 2. Great! Now we know the radius and the side length of the square. So let's calculate the areas. First, the area of the square is r squared, which equals 5 over 2 squared. That's 25 over 4. Next, the quarter circle. The area of a quarter circle is pi r squared over 4. Substituting r equals 5 over 2 gives pi times 25 over 4 divided by 4, which simplifies to 25 pi over 16. Now for the final step. The shaded area equals area of the square minus area of the quarter circle. So we have 25 over 4 minus 25 pi over 16. To combine the fractions, multiply the first term by 4 over 4. That gives 100 over 16 minus 25 pi over 16. Therefore, the exact area of the shaded region is the quantity 100 minus 25 pi, all divided by 16. And that's our final answer. If you love clever geometry problems, be sure to subscribe, and I'll see you in the next one.